Alright, so welcome to part 2 of this video. We had left off kind of in the middle of question number 3 here with a couple formulas left to right. So we've got iron 2 hydroxide and we've got ammonium nitrate. So we're going to look at iron 2 hydroxide here first. We're going to go back to our drawing board here. So remember, the first thing we do is to write out the symbols. So we've got iron. And remember, that Roman numeral means that it has a +2 charge, and the reason we put that Roman numeral there is because it's a transition metal. And hydroxide is also a polyatomic ion, and you're going to find it on the back of your periodic table. If you go down to, let's see, hydroxide is going to be on the right-hand side at the top of the column, and you'll notice that the formula is OH, and it has a -1 charge. So you can either just put a minus or you can put a -1. So then our next step is to take the 2 and put it down here. And we're going to take this 1 and put it over here. Now remember, we don't need to write ones, so when we write our formula it's going to look like this. Remember that OH is a polyatomic ion, so the O and the H are always going to stay together. So in order to put our subscript in there, we need to use parentheses again. And we're going to put our 2 outside of the parentheses. So this would be your final chemical formula. All right. The last one is ammonium nitrate. This is 2 polyatomic ions. Whoops, I'm sorry, that's the wrong screen. We go back to our drawing board here. So we have 2 polyatomic ions this time. So we're going to find both of these on the back of your periodic table. So ammonium is one of the few positive polyatomic ions. So ammonium is at the very top left-hand corner of the back of your periodic table. And you'll notice that its formula is NH4, and it carries a +1 charge. So it's plus, we'll just put a plus this time. And then nitrate is going to be down towards the bottom on the right hand side. Nitrate is NO3. Sorry for my sloppiness here. And it also carries a -1 charge. So in this case, they're both 1. So when we crisscross to put the numbers down here, we're just putting 2 1s down here. So in this case, with polyatomic ions, you only need to use parentheses when you're using an extra subscript. So since we're putting a subscript of 1 next to each one of these, meaning that we just want 1 of this ion and 1 of this ion, we don't need to use parentheses in this case. We just write the 2 polyatomic ion formulas right next to each other, and this is your final chemical formula. All right? So that tells us that we have 1 ion of NH4 and 1 ion of NO3, and that's our final formula. All right. Now your next question is, how can you check to make sure your formula is correct? So let's go back to the one we just did here. And you can do this for all formulas, not just polyatomic ions, but anytime you're writing a formula, you can always do this same check. So if we look at the charges, we had a +1 and a -1. The charges always need to equal 0 when you add them together. So in this case, +1 and -1 equals 0. So we just need 1 of this and 1 of this, and we add them together and it equals 0. So that's how we know our formula in this case is correct. Now if we look at one that's a little bit more complicated, let's look at, for instance, the formula for aluminum sulfide, which you'll, I think, look at later actually in this discussion. So aluminum sulfide is Al2S3. Whoops, I'm sorry, that's a really bad 3. There we go. So Al2S3. Now, in order to check this formula, you need to know the charges on aluminum and sulfur. So aluminum is a +3, and you can actually figure that out by just doing the reverse crisscross and putting this up here like that, and taking this and put it up here. And you know the positive ion always comes first, so this one has to be negative. So we know that aluminum is a +3 and sulfur is a -2. Now when we add these two numbers together, that obviously does not equal 0, and that's what we need to happen. So the reason that we need 3 sulfurs and 2 aluminums is in order to get these numbers to equal 0. We want the charge to be 0. So aluminum has a +3 charge, so we need 2 of them. We're going to times this by 2, which equals a -6. And we're going to take the other one, sulfur, which has a charge of -2, and we're going to times that by 3. Now, why am I timesing that by 3? Well, because in our formula we have 3 of them. Up here we had 2 aluminum, so that's why I multiplied by 2 there. So if we do -2 times 3, we're going to get sorry, this should be a +6 up here. We're going to get -6. What am I doing? There we go. Okay. We're going to get -6 down here. Okay. So now, do these two numbers equal 0 when we add them together? Yes, they do. So this is how you can check to see if your formula is right. If the oxidation number times the subscript of the first element plus the oxidation number times the subscript of the second element, if those two equal 0, then you know your formula is correct. So you can always check your formula to make sure that it's right. Alright, number 5, how would you describe the process of writing chemical formulas in your own words? So there's kind of 3 steps. Write out the ion, or write out the chemical symbol, I'm sorry, put the oxidation number up there, and then the last step is to crisscross the oxidation numbers. And remember that the positive ion always comes first, negative ion always comes second. Whoops, I'm sorry. I'm going to go back here. There we go. So number 6, then, write the names of the following compounds. So magnesium and oxygen, that's a compound. So the general rules here for basic ionic compounds are that you leave the first element in its same form. So for instance, magnesium, we're just going to call it magnesium. The second element, you chop off the normal ending and you replace it with IDE. So for instance, in this one, we would call it magnesium oxide. So that would be the name for that simple binary compound. Okay. The next one, Al2S3, that's the one we just looked at actually. It's a simple ionic compound. There's no transition metal, there's no polyatomic ion, there's nothing fancy. So again, we're going to do the same thing. The first element is going to stay the same, so we just call it aluminum. Second element, we're going to just chop off the ending and replace it with IDE. So instead of sulfur, we're going to call it sulfide. So the name of Al2S3 would be aluminum sulfide. Now the next one gets a little bit tricky because in this one we have a transition metal. So if we look back up to number 3 up above, up here, you'll see that we used a Roman numeral in any of the ones that had transition metals. Now, some of you might be thinking, well, how am I going to know what Roman numeral to put in there? So first thing that we're going to do is we're going to name this just like we name any other ionic compound. The first element is going to stay the same. Second element is going to get changed to IDE. So this is going to be iron sulfide, but the thing we need to add in is going to be the oxidation number. Now the way in which you can figure this out is to do a reverse crisscross. Okay, so let's look at this for a moment. So the formula that we're given is FeS. Okay. Now Fe, we don't know the charge on it because it's a transition metal, so it could have multiple different charges. Sulfur, we do know the charge on, okay, and we know that it has a -2 charge. So the fact that there's no subscripts down here tells us that we only have 1 iron and 1 sulfur. And remember, our compound needs to be neutral. The oxidation numbers need to equal 0. So -2 times a 1 subscript here equals -2. So over here with a 1 subscript, we're going to need a +2 in order for our oxidation numbers to equal 0. So that's how you can figure out what the oxidation number is to kind of do a reverse crisscross and make sure that the oxidation numbers times the subscripts equals 0 when you add them together. So now we know that iron is a +2. So if we go back to our questions here, the name for iron sulfide in this case is going to be iron 2 sulfide with the 2 in parentheses just like it is up here. Okay. Now this next one we have a polyatomic ion. And polyatomic ions are actually kind of nice because you don't need to know how to name them. You're just going to look at the back of your periodic table to find out what the name is. So with our other ionic compounds, the first element stayed the same. That still applies to this compound. So sodium is going to stay the same. So we're going to call this one sodium. And then OH is called hydroxide if you look on the back of your periodic table. So this one is just going to be called sodium hydroxide is the name. Okay. So the polyatomic ions are kind of nice because the name is right there for you. The next one here we have copper, and this is a polyatomic ion called sulfate. So this one again is the first element's going to stay the same, so we're going to call it copper sulfate is the name of that one. This one here you have 2 polyatomic ions, so this one's really easy. All you got to do is look at the back of your periodic table. This one is called ammonium. This one is called carbonate. So this is called ammonium carbonate. Okay. This one here, Al2O3. This one is also an ionic compound, a metal and a non-metal. So this one is going to be a simple one. It's aluminum and then oxide. We're going to replace the ending with IDE. Okay. All right, and then we're going to take a look at these last two here. We have obviously this next compound is water. However, water also has a scientific name to it as well. And these last two compounds are covalent compounds, you'll notice, because they're between 2 non-metals. And so this first one, hydrogen, the subscript of 2 tells us that there's 2 hydrogens, and no subscript tells us that there's 1 oxygen. And so when we name covalent compounds, the naming rules for ionic compounds still apply. It's just that we also add a prefix to tell us how many atoms of each element are present in the compound. So this 2 tells us that there's 2, so we're going to use the prefix di to tell us that there's 2 hydrogens. So this is going to be dihydrogen. And then for the second element, you always use a prefix no matter what. So even if there's only one of them, you're going to add a prefix in front of it. So in this case, this would be, we're going to use the prefix mono. So this would be called dihydrogen monoxide, is the scientific name for water. Okay. This is a compound that we're familiar with, and we're familiar with the scientific name, which is carbon dioxide. You'll notice I didn't use a prefix on the first one because there is no subscript. So on the first element, if there's no subscript, you don't need to use a prefix. On the second element, we always use a prefix. Okay, on the first element, unless there's a subscript, you don't need to use a prefix to describe it. All right. So number 7 then, how would you describe the process of naming chemical compounds in your own words, or what are the rules? Just to kind of summarize the rules for basic ionic compounds would be that you leave the first element the same, the second element you change it to IDE. Some kind of extras or some exceptions to the rule would be if there's a transition metal, then you need to include the oxidation number in parentheses within the name. If there's a polyatomic ion, then you simply look at the back of your periodic table to determine what the name is, and you use that name to name it. Okay. As far as covalent compounds, you're going to name it the same way you would an ionic. First element stays the same, second element you change to IDE. However, with covalents, we're also going to add in the use of a prefix if the subscript is greater than 1 on the first element, or any time on the second element. So even if the second element doesn't have a subscript, you're still going to use a prefix to tell us how many there are. All right. So that's today's discussion. I know that was a long, kind of extended discussion answers video, about almost a half an hour total. So if it takes you 2 days to watch this, that's probably fine. And again, if you have questions about things, we will spend at least a day or 2 when I get back going over a lot of this stuff together. So make sure you write down those questions so you can get them answered. All right, I'll see you guys when I get back.